good day, everyone. And once again, we are looking at yet another series, just looking at the electrolytic cell. All right, so if you haven't subscribed, please just make sure you do the right thing, all right, and be part of the family. And thank you to all of you for just journeying with me through this phase. All right, now let's get right into the question. So, they say to us, we've got the diagram below shows an electrolytic cell used for the refining of copper in industry. Right. So the first question there. Oh, and by the way, just for me to say, please don't be afraid of the electrolytic cell, right? Because it really isn't that bad a section. Okay, it's just a theory part that is just a little bit not comfortable, but nonetheless it is doable. Okay, right. So they say state the energy conversion that takes place in the electrolytic cell. So we know that the electrolytic cell will always convert electrical energy to chemical energy, right? Now, this is obviously in stark contrast to the galvanic cell that converts, chemical energy to electrical energy. Sorry, I forgot to write energy in both instances. Okay, right. So 9.2, they said what will be observed at the cathode. Now let's just have a look at this cell quickly. So you've got the negative side that would obviously make this electrode negative. Okay, so this guy becomes negative because he's connected to the negative part of the cell, and this side becomes positive, right? So now what's going to happen? Remember, you've got copper sulfate, which means that you've got copper 2 plus ions that are deposited into, that are in the solution, right? So you've got copper 2 plus there. So what will happen on the negative electrode is that your copper 2 plus ions would be attracted to this side. So therefore, they would gain those electrons, right? So reduction would take place there. And in this case, you'd find copper being deposited there, right? So remember where reduction takes place, that's the cathode. So they're asking what will be observed at the cathode. Okay, so it means that we'll see copper being deposited there. So copper will be deposited, or you can even say, it might experience an increase in mass due to copper. Okay, so you can say something to that effect. Okay, right. Now, they say to us, write down the half reaction that takes place at the anode. Now, ladies and gents, I looked at this question and I really was not too sure about it. Okay, so at the anode, so I don't know whether they wanted to say, well, the nitrate, remember you've got, copper sulfate rather, whether sulfate would, undergo oxidation. And in that case, I really wasn't too sure what they were looking for. So honestly speaking, and I would please ask that examiners really, really be careful of these kind of questions because they do cause a certain amount of confusion. So we skip that question, all right? Right, and then the final part, they say what will happen to the color of the blue copper. Oh, by the way, just maybe to make up for this question for 9.3, what I would say is if I were an examiner, I would have said at the cathode, right? So in that case, if they had said at the cathode, it's quite clear that we would now take copper 2 plus 2 electrons, which would give us copper. Okay, so this is not, purification or even electroplating. So it's not the same reaction that takes place. So in that case, I think you might go and check in your standard reduction table if there is a reaction for, for nitrate. For sulfate. I don't know why I keep saying nitrate. Let me just check in mine just here. Yeah, there is one that I see but you see it's actually written the other way around. There's no such a reaction where the sulfate ion actually gives away electrons, which would have to be the case. So yeah, I would definitely say this question was incorrect. So for the cathode, this would have been the reaction. Okay, right. Now they say to us, what will happen to the color of the blue copper sulfate solution? Right, now copper 2 plus ions are usually blue in color. But now remember what's going to happen, right? More of them are actually taken away. They undergo reduction, okay? So in this case, what will happen to the blue color, because you keep taking them away, the blue color will fade away, okay? So the blue color will fade. Will fade, okay? Right, and ladies and gents, that's essentially it. You would have picked yourself up a good 4 marks. Well, in this case, obviously, question 9.3 was really virtually impossible. Okay, right. So, we'll see each other again next time. Sharp, sharp.